Assalamu alaikum everyone, and today we are going to be talking about one-dimensional and two-dimensional motion in physics. In physics, we are going to be dealing with many different kind of motion. How motion occurs through a force, how we can predict motion, and a few terminologies that we have to use to communicate more about motion. We today are going to be discussing about that last one, terminology that is used to communicate the motion of objects. And today we will be discussing one-dimensional motion and a little bit of two-dimensional motion. The first terminology of motion you have to understand is position. Position is the key part of understanding motion. It is where an object is located, and it is said to be some distance away from a reference point. So for example, when you're a pilot, you don't just vaguely say your position as we're high in the sky. You say something along the lines of we're cruising at 32,000 feet altitude, where 32,000 feet is a distance that the aircraft is from the ground as being the reference point. So it's sort of the y direction of the aircraft. The next definition we are going to be aware of is velocity. Velocity is change in position per unit time. Velocity is change in position per unit time. So say you're in a car and you traveled 4 meters in 1 second. Don't ask me why you stayed in the car for only 1 second. It's not relevant. So 4 meters in 1 second would mean that you were going at a velocity of 4 meters per second, or in car terms, 14.4 kilometers per hour. Here we're using distance as position, and for this we're going to be looking over more in depth later. Next we have to look over is acceleration. Acceleration is change in velocity per unit time. So say you're in a car again and you go from 40 kilometers per hour to 60 kilometers per hour in a given time interval. So you are going to calculate your acceleration at that given time using this. And say if you were going from at rest to all the way 100 kilometers per hour within a time interval, then you're also going to use similar methods. Now that we've done with the definitions of position, velocity, and acceleration, let's talk about them a little more in depth. So position can be expressed with a distance or displacement. We use displacement. The only difference between distance and displacement is distance is a scalar. We are 5 meters away. We don't know at what direction we're 5 meters away, maybe north, south, east, west, but we know we're 5 meters away. Displacement offers a vector. So, and it is the straight line between point A and point B. So your distance can be all the way around the place. Your path can be all the way around. And that path that you went through can be your distance. But your displacement will be from your point A to point B. Let me show you this as an example. Say you were taking a walk in the morning. You and your friend is going through the from the pavement back to the house. So your friend uses the very normal path, 30 meters down the path, and then 5 meters up the driveway. But you are a little more, what's the right word? Efficient. You want to travel in a straight line from your intersection all the way to your house, going through all the grass. So whereas your friend traveled a distance of 30 meters plus 5 meters, which is 35 meters, we can use the Pythagorean theorem to find out your distance, which is 30.41 meters. And whereas you guys traveled different distances, you guys had the same displacement, because point A is the point that you and your friend is starting from, and point B is the house itself. So whereas your friend went 30 meters and 5 meters, he still traveled the 30.41 meter displacement. And distance can go all over the place, but the displacement between point A and point B does not change. Next, let's talk about velocity. Velocity is change in position per time. Now, in common language, velocity and speed are very interchangeable, but in physics, they're not. Speed is a scalar, velocity is a vector. So say you're playing hide and seek, they all can go at the same speed, but they're gonna have different velocity vectors to indicate at what direction they're going. Say your friend is going 2 meters away from you, but you don't know which direction. It can be east, west, north, south, right, left, top, down, whatever. Your velocity is going to give you that. Next, we're going to talk about acceleration. Acceleration is change in velocity per unit time. Acceleration is also a vector. It is also a vector, and when you apply a force to give an acceleration, you feel a sort of push that pushes you to the seat. That is your inertia, and we're going to be discussing that later, and it is related to your acceleration. Now, if you're a non-physicist, you would calculate all your position, velocity, acceleration, blah, 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 in a map. You know, map is easier, map is much more clean, and all that. But us physicists would like to use it in a graph. Graph can be conceptualized much better. You can talk about data much more accurately on a graph than a few lines scribbled on maps. So we'll use that. To see how we can explain position, velocity, and acceleration through a graph, let's take an example. Say you're in a car and you traveled 5 kilometers in 5 minutes to a restaurant for some snacks. You stayed there for 10 minutes. Then you traveled at a displacement of 10 kilometers in 5 minutes to your friend's house, where you stayed there for 30 minutes. Then you traveled 15 kilometers in 10 minutes all the way back to your original location. Here we can describe it in many ways. First is your position curve. So we first make a graph describing the entire hour. Then we make a y-axis describing all of your distances, since position, velocity, and acceleration is described on the y-axis. So at first you traveled 5 kilometers in 5 minutes. So your coordinate is 5, 5. You stayed in the restaurant for 10 minutes. So you're gonna be shown at rest for 10 minutes until t is equals to 15. Then you travel to your friend's house, that's all the way at 15 kilometers in 20 minutes. So you are going to be shown that. Then you stayed there for a certain amount of time, and then you went all the way back to your house, and this will be your position curve. And this position curve is very important because it will be describing your velocity curve. A velocity curve is where the velocity is in the y-axis and t is in the x-axis again, and you get only velocity data when position is changing, and it would look something like this. Now note this, that your velocity data is curved because of the fact that you need some time to go from rest all the way to a certain velocity. It doesn't just happen at an instant. And similar for acceleration. You get acceleration data in velocity. And as you can see, the graph ends at a positive acceleration because it takes some deceleration in the opposite direction to use. Now, if you're well versed in calculus, you know that we can describe these changes as the derivative of something. So your velocity is the derivative of position with respect to time, and your acceleration graph is going to be your change in velocity with respect to time. So that's all there is to it. Thank you for watching, and please make sure to like the video and subscribe and share to anyone who might need this video and who is interested in this video. And thank you for watching, and I will see you next time. Bye.